Part 12 traced a bear class attribute in XML all the way to a live admin grid object. Today we trace something you have almost certainly typed into a terminal without ever asking how it works, a bin/Magento command. Every single command the CLI offers, whether it ships with core Magento or comes from a module you wrote yourself, is discovered by exactly the same two real methods on exactly the same real class. We are going to open that class, read the real code that decides which commands exist, look at a real shipped command end to end, and by the end you will know exactly what 4 things a brand new custom command actually needs. Every file and every line comes from a real get checkout of the pin 2.4.9 tag. Welcome back to Magento Development Deep Dive. This part is about console commands, the system behind every bin/Magento subcommand in the framework. We're narrowing the scope to one concrete question: how does a PHP class you write end up listed when someone runs bin/Magento list, and what does that class actually need to contain? We'll trace the real bin/Magento entry script, the real CLI class that does the discovery work, the real interface every command bundle implements, and a real, complete, shipped command cron: install using ground truthline numbers from a local checkout of the pin 2.4.9 tag. By the end of this part, 5 things should click. What the real bin/Magento script does, in plain PHP, before a single command actually runs. How CLI's real getApplicationCommands method finds both core Magento commands and commands shipped by third-party vendors, using 2 genuinely different code paths. What the real CommandListInterface and its default CommandList implementation actually require of you, which turns out to be very little. How a real core module, cron, registers its own commands purely through di.xml configuration, no special bootstrapping needed. And the 4 real pieces a brand new custom command needs, illustrated with a real, complete, shipped command rather than a toy example. Strip away the code and every CLI invocation goes through 5 stages. Entry, bin/Magento runs, requires the framework's bootstrap file, and constructs a real CLI object Magento's own subclass of Symfony's console application. Discover, that construction triggers the real getApplicationCommands method we're about to open, which finds every available command from 2 separate sources. Register, for module-shipped commands, that discovery ultimately reads real di.xml configuration, the same declarative configuration pattern this series keeps returning to. Load, once a class name is settled, Object Manager the same one from Part 3 builds a real instance with its dependencies injected. And run, Symfony's own console component matches whatever name you typed against the loaded commands and calls that one instance's execute method. A few things help before we dig in. Part 3, on dependency injection, is directly useful. di.xml wiring a class into a framework list is the exact mechanism this part relies on, just for a different interface. Part 4's plugin chain or Part 12's UI component factory both help too, since both already showed Object Manager turning configuration into a live object. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab, so you can follow along in the real files. No prior command line or Symfony console experience is needed. We build the concept up from the real, complete source. This is the real, complete bin/Magento script, trimmed only for the try-catch wrapper around it. It first checks it's actually running under the CLI SAPI, not a web server. Then it requires the same app/bootstrap.php file every single web request also goes through. There is no separate console bootstrap. Finally it constructs exactly one object, Magento_framework_console/CLI, and calls run on it. That constructor is where everything interesting happens, and that CLI class is Magento's own subclass of Symfony's console application. This is the real getApplicationCommands method, trimmed only for its try-catch error handling. It does exactly 2 things. First, if Magento is actually installed, deployment config is available. It asks Object Manager to create a CommandListInterface, and merges in whatever getCommands returns. Second, completely separately, it merges in whatever getVendorCommands returns. 2 genuinely different sources, 1 array. Core Magento commands come from that single CommandListInterface object, everything else comes from the second path we're about to open. This is the real getVendorCommands method, trimmed to its core loop. The full version also catches and logs exceptions per class, so one broken vendor command can't take down the whole CLI. It iterates every class name returned by CommandLocator: getCommands, skips anything that isn't actually loaded, and for everything else, does the exact same 2-step. Part 12 already showed you. Object Manager creates an instance, then getCommands is called on it. This is the real second half of that fork from step 2, and it's how a completely separate installer or standalone tool can inject commands without touching core di.xml at all. This is the real, complete CommandLocator class, all 24 lines of it. It's deliberately tiny, a static array, a register method that appends a class name, and a getCommands method that returns whatever was appended. This is exactly what getVendorCommands looped over in step 3. Anything, anywhere, that calls CommandLocator : register with a class name implementing CommandListInterface gets picked up automatically the next time bin/Magento boots. No di.xml required for this particular path, just a static call. This is the entire real CommandListInterface 1 method, getCommands, returning an array of Symfony command objects. And this is the real default CommandList class that implements it, which step 2's core commands path actually creates. Notice the constructor just stores whatever array it's handed. There's no hard-coded list anywhere in this file. Every core command you've ever run got into this array through di.xml configuration, injected as constructor arguments, exactly the same array argument injection pattern part 3 already covered for ordinary services. This is the real di.xml block from Magento's own cron module, trimmed to one of its 3 registered commands. It targets CommandListInterface directly and adds a commands array argument. Each item is a name, and a fully qualified class string is an object reference. This is the exact array that reaches CommandList's constructor from step 5. If you're writing a custom module and want a new bin/Magento command, this block pointed at your own class is the entire registration step. No CommandLocator call needed for this path. This is the real configure method from cron::install, a genuine, currently shipping Magento command, trimmed to its first option. Every custom command overrides this exact method. Set name is the string you type after bin/Magento here, cron::install. Set description is what shows up in bin/Magento list. Add option declares a real flag, --force or its short form -f, with a help string. This is the entire first of the 2 methods a custom command needs to implement. This is the real execute method, trimmed to its first guard clause. The full version goes on to actually save the cron tab. Every custom command overrides this second method too, and it's where the actual work happens. It receives input and output objects, checks the real --force option through input arrow get option, writes a real error line, and returns one of 2 real integer constants, Cli::, return _success or return _failure, defined right on that same Cli class from steps 2 and 3. Configure plus execute, backed by a di.xml registration that's the complete real shape of a custom Magento console command. A few things trip people up here. Core commands and vendor commands are 2 genuinely separate code paths inside getApplicationCommands. Registering through di.xml alone puts you on the CommandListInterface path, not the CommandLocator path, and the 2 are not interchangeable. A broken vendor command class is caught and logged per class inside getVendorCommands, so one bad third-party command doesn't take down bin/Magento list. Entirely worth remembering when a command seems to silently vanish. getApplicationCommands only pulls in that first CommandListInterface bundle once deployment config reports Magento is actually installed, so an uninstalled instance genuinely sees fewer commands, not a bug. And always return the real Cli::, return _success or return _failure constants from execute, not a bare 0 or 1. It's the same class, same constants, every shipped command already uses. Let's pull this back together. Bin/Magento boots the framework exactly once, then constructs a single real Cli object, Magento's own subclass of Symfony's console application. That object's real getApplicationCommands method forks into 2 paths: a core CommandListInterface bundle, and a separate CommandLocator-driven vendor path, and merges both into one array. CommandList's own constructor just stores whatever array di.xml hands it. There is no hard-coded list anywhere in the framework. A real module, cron, wires its own commands in with nothing more than one di.xml block targeting CommandListInterface. And a custom command itself needs exactly 2 overridden methods, configure and execute, exactly as the real, shipping cron::install command shows. That's the real machinery behind every bin/Magento command, straight from a git checkout of the pin 2.4.9 source, every file and line verified against that exact commit. Part 14 moves to the web API wabapi.xml, REST routing, and how service contracts from Part 6 get exposed over HTTP. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in Part 14.